So a function is a special type of relation, okay? It's a special type of relation that has one... Where'd it go? All right, one and only one output for each input. So let's talk about what this means. Output, what's output? Is that X or Y?
Y.
That's Y. Input then would be, okay? So every X value only has one Y value that corresponds to it. John, put that phone away. So I'm going to show you what this looks like as we map. Remember how we did the mapping yesterday with the numbers? Y'all came up here and drew the arrows? Okay. I'm going to show you what it looks like by a mapping chart, and I'm going to show you what it looks like on a graph, and I'm going to show you what it looks like in a T-chart. All right, I'm going to show you two mapping scenarios. One of them is going to be a function, and one of them is not going to be a function. And I want you to tell me which one's which. Only one output for each input. Or only one, every X can only have one Y that goes with it. Okay? All right, let's do...
Dang, slow down.
I'm just writing it up here. It's going to be two separate...
Yeah, you don't mind.
I'm sorry.
Boom. No, put that in. Shoot. When do we get over this?
Never.
Can I have Corona, please?
All right, shh.
You've been pointing too. You still can catch it.
No.
We're going to look at each one and decide which one's a function, which one's not, and what's going on.
This is the thing you put the calculator. You pop over a whole bunch of extra stuff and then you can put it on the graphic paper and all that extra stuff.
We are going to put it on graph paper, yes. All right, here's what I want to look at first. Does every X value only have one Y that goes with it?
No.
So look at this one. Does every X only have one Y? Yes. Negative 3 and 5, 0 and 3, 2 and 2, 4 and 1. Right? Every X only has one Y. That means this is... All right, so this is a function because every input only has one output, or every X only has one Y. Okay? Look at the next set. This one looks a little bit different, right? So let's think about it. All right, so Precious is not a function. Does every X only has one Y? How many Y's does that one have? One. It's negative 3, right? How many Y's does 0 have?
1.
1. 6 goes with that. How many Y's does 3 have? 1. Look, for 3, it's only going to 6. How about 4? How many Y's does it have? 1. So it is a function. These are the most confusing to try to determine functionality on, in my opinion. And I have to ask myself that. How many Y's does this one have? How many Y's does this one have? If one X has more than one Y, it's not a function. Look at this bottom one. You know I was going to give you one that's not.
Wait, one X has more what?
has more than one y.
I can't.
Well, look at this one. Look at the number 2. That's your x, right? How many y's go with that? 2. You see those arrows? You see how it's got 2 arrows? It's going here and going here? Not a function.
I never understand this thing.
All right, that's mapping. Okay? Let me take these same numbers and show you in a T-chart, because then that's a whole other thing. So this is mapping. I'm going to take these same and I'm going to change them to a T-chart. All right, so first, you know the difference in a mapping chart and a T-chart, right?
Yes.
Okay.
Yes, ma'am.
So T-chart's going to list every single point. All right, so here I got -2 and -3, 0 and 6, 3 and 6, 4 and 9. Do you agree that that's the same one as the one on the right? This and this are the same? The one circled in yellow and the purple one I just drew are the same. -2, -3, 0, 6, 3, 6, and 4, 9. Okay? All right, I'm going to erase that one. And now I'm going to do the other one because I want you to see how it looks different.
Yes, ma'am.
Come on. All right. You give me the points. Look at that mapping there at the bottom. But tell me the points in it. 2, 2, 6.
3.
Wait, give me the other one here. 2, 2, 7. Keep going. 3, 3. 5, 2. All right, now let me erase this one. Now I want you to look at it because it looks different. We said this is exactly the same thing, just written a different way, right? And we said that this first one is a function. But look, see how I have 2 y's? Is that okay?
No.
But you told me it was a function. All right, it's still a function. Because think about it like this. Every x can only have 1 y. How many y's does 0 have? How many y's does 3 have? It's still a function. Every x can only have 1 y. With anything. But this is a T-chart. Every x can only have 1 y. Look at the pink one. How many y's does 2 have? Look at it. I got 2, 6, and 2, 7. That's the same x with 2 different y values. So how many y's does x have? 2. This makes it not a function. When you look at it in a T-chart, x cannot repeat. Does that make sense to you?
Yes, ma'am.
Okay, let's look at it as a graph. I forgot to hit record. All right. Look at the first one. Function or nah?
Function. Yeah.
Why?
Good. It passes the vertical line test.
It passes the vertical line test. Vertical's up and down. This is a function. Look at the second one.
Yeah.
Function or nah?
Yeah.
Sure? Does it pass the vertical line test?
No.
What if I put my vertical line right here? How many times will it touch the graph?
Never mind, I'm not saying
Twice. So it fails. So this is not
Holy crap.
a function.
that. So what if you put your vertical line sideways on the other one?
Then it's a horizontal line.
Right?
All right, questions about that and looking at the graph? I need to show you one more thing and I'll be done. And that is what we call function notation. Function notation is just a way of naming an equation that lets us know why, yes, as a matter of fact, it is a function. Okay? So we use this funny looking notation that I hope you have seen before. An F with an X in parentheses.
Why did they say no snake?
We call this, you probably broke it, F of X is how we read that.
We got right from that.
Yes. We can use it to take the place of Y. So if we have something like Y equals 2x plus 3, because I know that 2x plus 3 is a function because I'm telling you it is. Yeah, that's a Y. We could rewrite this as f of x equals 2x plus 3. Don't get caught up with it looking bad because it's just a way to name the function. Now, what you do need to know how to do is to know that whatever is in these parentheses goes in for every variable in here. So, for example, y'all got that?
It's cold.
All right, let's say I told you. Say f of x, I'm recording now. Let's say f of x is 2x plus 3. Let's say g of x, because I can name it whatever I want. This is just a way to distinguish between functions, okay? Let's say g of x equals 5x. What if I said, Fisher? What is f of 2? What does that mean that I do?
F times 2. I don't know.
Everywhere, look what was here before. Before it was f of x, right? Now it's f of 2. Everywhere there was an x, replace it with 2. 2.
2.
This is a multiply here.
2 multiplied 2. Plus
2 times 2 plus 3. 4 plus 3, which is what?
What was like 7?
Y'all did 4 times 3. Okay.
Shut up, Billy.
What's g of negative 1? Huh? Huh? What is g of negative 1? Somebody, anybody, anybody. Look at g. This is telling me, look at g. Where there's 5 times negative 1, which is all of you find f of 0. What is f of 0? What did you get for f of 0? 3.
How?
How did we get 3? So we look at F and we say, okay, everywhere.
No.
Are these two different problems? G and F?
That's 2 different equations, and I'm telling you which one to look at to plug into. Okay? This time, Fisher, this time I'm telling you to look at F, and I'm telling you for the equation F, everywhere there is an X, replace that X with 0. So 2, not X, but 0 plus 3.
It's just 3.
It's just 3.
No. Plus 3.
What does that equal?
Oh, nothing. G5. It's A5.
Five.
It's just, there's,
What did I tell you? Whatever's in parentheses.
I mean, you'll do 2 times A plus 3. Right?
Look at G.
Oh, no, 5 times. I said so.
Did you? I'm sorry, I didn't hear you.
Different way.
Whatever is in parentheses is what goes in for X. I don't feel it. Fisher?
Yeah. Oh, sorry. I was.
Shut up. Just shut up.
Shut up.
Fisher.
Yes.
Solve it.
Solve it, sister.
Yeah, I know I'm a G.
Solve it. What does it equal?
I don't know.
5 Fisher.
It
Five
does.
Fisher.
5 Fisher.
There's 5 Fisher.
There you go.
Oh, no.
Can't handle 1.
1, 2, 3.
Do you see what I'm doing?
Yes, I know.
Yeah, you said Fisher.
Okay. The point that I'm getting at is no matter what is in that parentheses, it's replacing the X. No matter what.
I must be like right there. Wait.
Let me show you one more.
It's still cold.
Right here.
Let me try to.
It's stalled out.
Yeah.
I'm gonna just go to another page.
See, but now I'm too social distance. She could with a piece of paper and block it off.
What was f of x again? Tell me what f of x was. 2x plus 3. Guys, stay with me. I'm almost done. And g of x was 5x. Is that right? What is f of x plus 1?
You just do 2 and then parentheses x plus 1.
You're exactly right. It doesn't matter what it is, it replaces x. Can you simplify that? Sure, you just did it on your quiz.
2 times x, 2x, 2 times 1, 2x, plus 2, and plus 3.
And you can put the 2 and the 3 together.
So it's 2x plus 5.
What does that mean?
5.
Okay, so g of x, you're on the right track though. G of x is what? 5x. I got this 2 out here. G of x I know is 5x. What's 2 times 5x? You can do this. 10x. All right, let me give you your work.